Hi everyone, my name is Stephane Begaudeau. I'm a software engineer working at Obeo. And today I will present you a tool that I've created in order to leverage the information that we have within our Eclipse IDE. And this tool that I've created, I've named it Ariadne. So first of all, I'll start by saying that Ariadne is an answer. What I mean by that is that it's not a technology that will change the world or revolutionize everything. It's just a pragmatic answer to a set of problems that I had while working on Eclipse projects. So the origin of this problem came from several occasions, but mainly on EclipseCon US this year with, for example, the presentation of Wayne Beaton's work on project.eclipse.org to help manage the metadata and all the information related to Eclipse project, and it highlighted a solution on how to have a better tooling to help the management of Eclipse project. And for the release review of my project for Eclipse 4.2 Juno, I've started to ask myself some very simple questions, and the more I looked for answers, the more I realized that I had even more questions than at the beginning. So if Ariadne is an answer, what are those questions? So my first question was, what are all the APIs of the Eclipse release train? All the projects, all of them. I want to know what I can build with the Eclipse platform, and I wanted to know what was accessible. And I couldn't find any kind of reasonable answer. Even if I started to look for just new APIs, or even just the APIs of one project, then I started to wonder, are those APIs tested? I mean, we can have code coverage tools telling us that we have a great code coverage, but we all know how to have, for example, 80% of coverage of our code with just one properly written unit test. It does not really tell me if the APIs are called directly from a unit test or not. What are the dependencies used while building all those projects? Are there any problem with them, incompatibilities, conflict? And there are. I stumbled on some of those. And what are the features of a project? Just a simple question, but the answer is not that simple. Which feature among those is the most stable, the most bugged? Or if I make a change, if I want to contribute to a project and I change one class, which features are impacted by this change? What do I need to retest afterwards? So while trying to figure out some answers to those questions, I quickly realized that all those questions have some common points. First of all, you have to ask 10% to have 11 answers. And if I want to know all the APIs of all the Eclipse release train, I need to talk to hundreds of persons, and I still won't have a really good answer. We all have a pretty good idea of the answer, and since we have this pretty good idea, we're not scared by this problem, really. Looking for the correct answer is painfully long, and I will need to check out maybe all the code of the Eclipse platform, and I will need to navigate in thousands of artifacts to start having a good idea of the answer. And we know where this answer is because we are manipulating all those data every day. So we feel that the answer is just a couple clicks away, which is not that wrong. So where is the answer? Well, it's right under our nose all day long. I mean, if we are wondering what our APIs are, well, the Eclipse IDE has the answer. When I make a breaking change in my API, PDE will tell me that I need to increment the version number of that specific API. So it knows what my APIs are, and it controls them very nicely. If I want to figure out what my dependencies are, for example, if I have two components that are using Guava, and I want to ensure that those components are using the same update site to have the same version of Guava, I can have the answer from my continuous integration tools. But I would need to navigate in, I don't know how many logs of Maven or things like that. If I want to see which features are the most bugged, the same thing. I can figure out the answer while navigating on Bugzilla, but it's very long. And for the stability, for example, of my code, I would need to navigate in Git, SVN, or Checkstyle, or CVS, sorry, repository. So, in a way, the problems feels a bit like a maze. I have various sources of data. For example, my platform, my frameworks, my continuous integration, my bugs, my technical artifacts, and so on. And what I wanted to do was to extract those information and to be able to connect them and use them. So, how to solve those problems? Well, the first thing that comes in mind is let's document everything. Yes, documentation is important, but it won't be enough for my need for several reasons. First of all, it's very long. I don't want to do it. It's too long. It lacks synchronization with the documented artifact. By the time I'm done documenting half of this, it will have changed already, and my documentation will be useless. And since I don't have any synchronization, I won't even know what to change in my documentation and how to properly maintain it. It cannot be easily manipulated by other tools. So at the end, I have a bunch of text, and I don't know what I will be able to do with this. It's error-prone. If I do it myself, I know it will be a real mess by the time I'm done. And as I said earlier, the information is already available, so why bother? So the documentation does not really match my need. What I need is something a bit stronger to analyze my projects. So I'm talking about projects at the beginning of this talk, but what is really a project in my mind? Most of the tools that I'm using to help me manage my project consider that a project is mostly code. And in my work, on my project, for me, it looks a bit more like this. So yes, I have code right here with my technical artifacts, but I have also very exotic artifacts, for example, manifest or extension point schema. I have all my settings for my development environment. I have my source code on various repositories, my continuous integration with the kind of artifact that have been built, the result of my unit test, everything. I have all my bugs, and I have the development environment itself, the runtime environment that my components will use, all the tools and their configuration within my Eclipse itself. So let's have a look at the architecture of Ariadne. So Ariadne can be described as three different parts. There are the structures in which the information will be stored, the connectors that are plugged in Eclipse in order to harvest the information and populate the structures, and finally the tooling that use the information from those structures. So first of all, there is the core structure, which contains cross-concerned entities that will be used in all the other structures, and it will be used to create links between the other structures. The source code one, which, as it says, describe all my technical artifact, continuous integration, of course, for the continuous integration, SCM for Git, etc., task, and the organization one, which will store information, an higher level of information to describe the project itself, the organization in which the project is created. So let's have a closer look to those structures. So for example, in the core one, we have concept, not all the concepts are described here. We have concepts like person, version, dependencies, or properties. In the source code, we have the various components that are in your project with the environment on which those components will be run, and types, for example, in your code. We have other concepts in this structure with fields, parameter, operation, provided and required services. In the other structure, we have for the continuous integration, the build server with their build jobs. We have the dependencies with those builds that are a bit specific. We have the task repository with all the tasks. For source code management, the repository, the commit, and all the branches. And for each commit, the resource that have changed. And for the organization, we have, as I said earlier, some concept that will describe the structure of your organization with the concept of release. So when you are making a release, you attach it to the component from the source code structure that you are releasing with the build job that matches this release and the branch that is built and all the tasks that have been, for example, fixed for this specific release. So on top of those structure, there's various connectors that are populating them. So I have a connector for Java, connector for continuous integration tools like Jenkins, Hudson. For the source code management, I have a connector for Git. And for the task management, a connector which will be able to harvest data from Bugzilla, Jira, etc. And then all that is plugged to the core connector, which is plugged itself in the user interface. So when you want to start the analysis, you just select a bunch of projects, launch the exploration, you select where you want to store your data and the connector that you want to use. And Ariadne's connector will be then launched to compute all the information from your project. So if you are using lots of Eclipse tools, we will be able to harvest lots of information. And if you are properly configuring your development environment, you will have a lot of interesting information in the end. You can always manipulate the computed data afterwards in order to fix some information, because we cannot figure out everything in your project automatically. So let's have a look at what Ariadne's connectors can do. So first of all, I start with the Java connector, which uses the Eclipse JDT. So it will analyze all the source code as long as all the additional files in your Java project, icons, licenses, build.properties, or any kind of artifact located in your project, pom.xml or things like that. It will build a dependency graph of your project and the other Eclipse projects in your workspace. And it will also use the JDT to build a graph of all the dependencies within your source code using import declarations and things like that. It will also attach properties to your code. So for example, if you have a Java class that inherits from JUnit 3 test case, we will attach the test property to this class. It will be the same thing if you have test annotation from JUnit 4. So we will attach various kind of properties to your code, and you can always manipulate that afterwards manually. So there is also a PDE connector, which is using the Eclipse PDE tooling as long as the API tooling. So it will reuse the Java connector for the analysis of the source code, and it will add a lot of information coming from your manifest, your features, in order to compute all the dependencies that are used by your project, because, for example, you may have some dependencies to other Eclipse plugins that are located in your target platform and that are not in your workspace. It will realize mapping of all the runtime environment using the target platform and the API baseline configured in your Eclipse. It will also realize a mapping of the development environment, so all the tools that you are using and their project-specific configuration for the selected project. So Checkstyle configuration, the configuration of the formatter, what kind of severity that you are using for your errors with the PDE or the JDT. All this information will be harvested. We will also attach other kind of properties to the code. Using exported packages from the manifest, we will be able to compute APIs and attach a proper versioning to the information computed. The Mylyn Build connector is pretty straightforward. It will analyze all the build servers synchronized, and we will analyze also all the jobs building the selected project, because with Mylyn Build, we have access to the components that have been built. We have also the result from the execution of the unit test. The Mylyn Task connector will use the setting of the project to figure out which task repositories are linked to a specific project. We will analyze all the tasks linked to this project. Mylyn Context gives us the ability to link a specific task to a specific technical artifact afterward. We have a connector for Git that uses EGit and JGit. It's also straightforward because it will realize an analysis of the whole Git repository with all the branches, tags, commits. We will also have all the changes on the resources, and we will link them to the analysis of the source code thanks to the platform team APIs. So after all this analysis, we will be able to manipulate the computed data with various tools. And with Ariadne, I'm using several tools to generate automatically some reports on the quality of my code. So this was an analysis of the source code of Axeleo. And by using the link resolution in Ariadne between the Git analysis and the JDT and PDE analysis, I have access to this view that shows me all the various components in Axeleo. So each color is a different Eclipse plugin. Within each plugin, I can see the features available. So those features are calculated, and then I've improved what has been calculated manually. So for example, we will be able to detect that we are contributing an editor with the extension point from the Eclipse UI plugin. So I will use this provided service in order to tell Ariadne, okay, this matches a specific feature in my software. So here you have a map of all the features, and you can see, for example, that some of them are more stable than others. So for example, right here, this small one here and there are the features matching the builder in the Axeleo parser and the Axeleo user interface. And you can see that those two are quite small areas because we have made several heavy refactoring in Axeleo on those two features. And if we have a look at the mapping between the bugs using Mylyn Tasks and Mylyn Context and the JDT and the PDE, we can see that those two components here had a lot of bugs raised against them because we can attach the bugs to the graph of the code, and starting from the extension point, we can compute the graph of the code linked to those two features. And it gives us the ability to have a bird's eye view of our project and to figure out what is stable or not in our project. We also have the ability to compute the dependencies between the project. So here we have, for example, all the user interface of Axeleo, which depends on pretty much everyone, while other components can be more easily used without all the rest. We also have access to here is the dependencies, but we've provided and required services, so using extension point and the volume of code linked to those extension points to see if we need to refactor one component, what will be affected by this refactoring work. So those are just examples of visualization that are provided by Ariadne. But since Ariadne is by default saving the data computed in a regular Eclipse modeling framework model, you can use any kind of tool from the Eclipse modeling project to manipulate those data and to use them. So by using regular Eclipse technology, Ariadne can be seen as a force multiplier. And one of those examples is with the Mylyn Intent project, which is a project that lets you document technical artifacts while linking your documentation to those technical artifacts and synchronizing them with those artifacts. So you will be able, with Intent, you are able to write a regular documentation, and then your technical artifacts are also referenced in your documentation. So if there are changes on the technical artifact, Mylyn Intent can ask one of its connectors to review these changes and analyze the impact on the documentation. What needs to be changed in the documentation because of a change in the technical artifact. And Ariadne can be used as a connector for Mylyn Intent. As such, by using Intent and Ariadne, you can have a synchronized documentation of everything that Ariadne can represent. So all your code, your target platform, your runtime environment, your continuous integration, etc. So in Intent, if there is a change in your technical artifact that needs to be reflected in your documentation, you have a small view showing the differences, and then you can apply the changes and in the documentation to have the documentation synchronized once again. You can also have rules that will tell you you have added a new release in your Ariadne structure. Now you need to declare a specific part in your documentation to document this release and to make sure that all your artifacts are properly documented. You can also have conditions and requirements on the technical artifact themselves. So for example, you can say you have an API, you don't have any other type with the property test that is using this API. So we feel that you are not testing this API, and it's wrong, and it will put an error marker in your documentation. So Ariadne is not a project located within the Eclipse Foundation, yet it's open source on GitHub with the Eclipse public license. So you can use it, fork it, copy it, etc. The roadmap for Ariadne, right now I'm working on performance improvement for the Java and PDE connector mainly, because they are manipulating lots of technical artifacts, and I have to navigate in a very large graph of codes. So I'm working on this. I will also soon release a Maven connector. So this connector is a bit different because it's a regular Maven plugin that you put in your pom.xml. It will analyze what's going on in your build, and then you will have in your output folder of your Maven build the Ariadne information. So it will help me, for example, to detect some problem. For example, I have two components using Guava, and one of them is using one update site, and the other one is not using the same update site. So I can't be really sure that they're using the same version, and it can create problems later. I'm also working on improving the link resolution with very precise support of Mylyn context, because Mylyn context gives us very precise information saying this bug is not related to just this Java class, but precisely this operation, for example. And I'm also working on new connectors. So Ariadne is extracting information from Eclipse and in order to give us the ability to manipulate those information. But Ariadne also provides a traceability. So it gives us the ability to go from what has been computed back to the IDE. So in the user interface or programmatically, once you have your data and you can, for example, use them with intent and you say, OK, this is my release. It's linked to those features which are linked to all those graphs of code. Now, give me the Java file that matches this specific operation of a specific type. The traceability information will give you the ability to go back and, for example, with the bugs that have been analyzed, you can open the Mylyn Task editor on the selected bugs. So you can go back to the original artifact. So that's it for this presentation. Thank you for your attention. If you have any questions. Yes?
So if I want to analyze or get information on a foreign project, do I have to import it first?
Yes. What I'm doing with Ariadne is that in order to analyze a project, I need the properly configured development environment because all these information have been properly set up by the developer, and I'm extracting what has been configured already. So if you're not using Mylyn Task or Mylyn Context, you will not have the same quality in the information computed, of course. Yes?
Would you then need to set up a second workspace with the same configuration?
To automatically set up the workspace? Yes, that's something that I want to do in order to launch Ariadne analysis in, for example, Tycho or things like that, to have a unit test that describes what should be configured, and then to have it automatically configured and the analysis launch just afterward. So I've not started working on it, but that's something that I would want, yes. Yes?
Do you also create one of the plugin XML and extension points?
Yes, we have an analysis of the extension point. I don't have the analysis of OSGI declarative service, but that's also something that I want to do later on. Well, thank you for your attention.